Hello calculus students. In this problem we're going to evaluate a limit where x is going to infinity, and it looks a little tricky because it looks at first glance that if you look at the dominant terms here, you take a square root of 9x squared, you would get a 3x, and you'd be subtracting a 3x, so it looks like you might get an infinity minus infinity, and so you might think like, well, the limit does not exist. However, I'm going to show you that that is not the case. Let's take this term and this expression here, and let's multiply it by its conjugate. Alright, so now I've taken the expression and multiply it by its conjugate, and you're going to see that we get a difference of squares. So I will be multiplying this square root times this square root. I'll multiply the 3x times the 3x, and then of course because we're going to have a plus minus with the middle terms, they're going to cancel out, and this expression here will become the denominator. Okay, so let's see what happens when we do that. Alright, so now I've got a difference of squares here, and I'm going to square this out, this term, and I'm going to square this term out, and you'll quickly see then that the 9x squareds are going to cancel, and we'll be left with an x in the numerator. Okay, so we do that simplification, and the 9x squareds indeed do cancel out. We get an x in the numerator, and in the denominator we have this expression, and we're going to now see what this limit is going to approach. Okay, so what I'm going to do is I'm going to get rid of all of this work here, and I'm just going to rewrite this expression here. All right, now that I have this expression rewritten, of course you're going to see that the dominant term here is going to be the root 9x squared, which will give us a 3x, so we're going to get an x over 3x plus 3x, and that'll be x over 6x as x is approaching infinity, and we'll get 1/6 as our answer. I just want to take a slightly different approach and show a slightly different technique to add a little bit of some algebraic rigor to this. So let's think about this again here. So I'm going to have 9x squared plus x in the root, and what I'm going to do is I'm going to divide by the dominant term, which is the 9x squared and the 9x squared. But since I'm taking the square root of that, I'm really dividing by 3x, because the square root of 9x squared is 3x, and it would be the same thing in the numerator. I would be dividing by a 3x. So as we're taking the limit, the x terms are going to cancel here, they're going to cancel here, and I'm going to get a 1 here, and this x will cancel with this x, one of these x's, and we are left with the limit as x approaches infinity of 1/3 in the numerator, and then we're taking the square root of 1 plus 1 over 9x plus 1, because 3 over 3 of course cancels and gives us, simplifies to 1, so I'm going to take this 1/3 and now pull it out of the limit. And you can see clearly now that the limit as x approaches infinity, this term is going to go to 0 as we take the limit, and I have a square root of 1, which is 1, so I'll have a 1/2, and so my final result is 1/3 times 1/2, which is indeed 1/6. Alright. So there's some techniques for you to ponder, and some algebra. Good luck.